What do I think should be the basic principle of the Gen 3 Formula E car? Well, it must accelerate from 0 to 200 km per hour faster than a Formula 1 car and cost a fraction of the price. To achieve this at the right price point and keep the racing exciting, we need to rethink race car design. How do we do that? First, people assume the technological evolution of electric motorsport is linear, evolving in the same way as before. But it's almost impossible to forecast which technologies will be available in 3 to 5 years, so this is the first false premise. Technological development is exponential and costs go down as technology evolves. The second false premise is that people also think an all-wheel drive Formula car is easier to drive than rear-wheel drive and that all Formula cars should be RWD because F1 has been like this for many years. Assuming these premises incorrectly could lead to a future where FE is not as interesting or relevant to fans or manufacturers. We should develop an electric race car from scratch, thinking about all areas from a pure physics standpoint, not copying a combustion-based Formula car and turning it to electric, as it's done today, including next season's Gen 2 car. For a start, the right approach for an electric racing car is to make it all-wheel drive, with electric motors connected to each wheel, not individually, as we want to control torque vectoring ability, but using a differential. On top of optimizing acceleration capacity, the front MGU, motor generator unit, results in more regenerative braking energy production than having the same weight in a battery. This has been verified in simulations. Simply put, a front drivetrain will weigh 70 kilograms, so you can take that 70 kilograms out of the battery because of the extra energy produced in braking. Counterargument: higher costs. The solution to this is to use the same MGU on the front and rear. Development cost is far greater than producing another motor unit. A symmetrical MGU race car, front and rear same spec, power, etc., is only a little more expensive than a one-motor car. We should develop an electric race car from scratch, thinking about all areas from a pure physics standpoint, not copying a combustion-based Formula car and turning it to electric. Looking more into the details, I found out that the total increment in development costs is not much more than €1 million, which represents around 10% of development, and if divided by all 11 FE manufacturers, is next to nothing. Another counterargument, that AWD cars are easier to drive. This is totally false. I have experience driving an AWD LMP1 hybrid car for 3 years and I can affirm this is not the case. Still in doubt? Ask any LMP1 hybrid or rallycross driver. There is no evidence that one is easier than the other. The next important step for the Gen 3 race car is that the battery should be flat on the floor, like every other all-electric car out there. Gen 1 and Gen 2 Formula E cars have the battery in a box replacing the fuel tank, which is not ideal. By having the battery flat, you can distribute weight in such a way that during acceleration the four tires have exactly the same load and therefore accelerate at maximum performance. The flat battery has more area for the same volume, which means cooling could be partially done by surface dissipation. A further counterargument: this is more dangerous. Not really. If you protect the battery in the same way with its own monocoque, it should be as safe as now. By my calculations, if the weight distribution is around 56 to 60% front and 44 to 40% rear, depending on the center of gravity, the car will dynamically have 50% to 50% distribution while accelerating at a constant, approximately 1.2 g, which is enough to beat an F1 car to 200 km per hour. Again, this is the end goal, so design should target 50 to 50 dynamic weight distribution. The good thing about having the weight forward is that you can also shift the aerodynamic distribution forward and therefore have a more aero-efficient car, which also decreases energy consumption. So how do we fit a car like this with roughly 500 kilowatts into super tight, often super bumpy, Formula E city tracks? My vision is that the power output should be modular. For tracks such as Mexico City and Marrakesh, we should unleash all the power. For Paris and Hong Kong, power should be shifted down according to maximum speed safety standards. In the same fashion as how F1 chooses its tires, the promoters, organizers will say Paris is a maximum 280 kilowatts, Monaco 350 kilowatts and Mexico 500 kilowatts, for example. Again, all of this must be done in a way that means only a few parts are open to development. The base technical model we have today is great and should be preserved. In an ideal world, the differences between the fastest and slowest cars on the grid should not exceed 0.5 seconds.